Hello and welcome to the SUSECON Digital. This is Abdurrahman Muhammad, an analysis solution architect at SUSE. I will present an SAP HANA HA cluster solution operating on Amazon Web Services. During this presentation, we will go through the following items: the relation between SUSE, AWS, and SAP, a brief about the AWS SAP HANA Quick Start deployment. We will talk also about the SUSE cluster components. We will have a look at the lab commands. We will discuss the resource agent constraints, and we finally test and manage the cluster. SUSE Linux Enterprise Server is available on AWS since 2010, so it's almost 10 years ago now. In 2016, SUSE Linux Enterprise Server for SAP applications was available on AWS Marketplace. Then the AWS team has released the SAP Certified High Availability Solution for the SAP HANA, supported and available on AWS Quick Start. So how SUSE, AWS and SAP teams have cooperated to facilitate the customer's need and achieve the customer goals. This diagram shows SUSE products and services. Also, it shows which SAP specific features are available from SUSE, like the installation wizard and YAST for SAP HA Solutions, SAP HANA Firewall, and workload memory management. SUSE provides the following SAP HA solutions: SAP HANA System Replication Performance Optimized HA Cluster, SAP HANA System Replication Performance Optimized Scale Out HA Cluster, SAP NetWeaver HA Cluster certified to run both ENSA 1 and ENSA 2. We are working on expanding the portfolio to introduce the SAP ASE Disaster Recovery solution. Now we will talk about the SAP HANA Quick Start. We have the AWS Cloud. Then we create the VPC. We will host our HA cluster on 2 availability zones. In each availability zone, a public subnet will be created. Then we will have the NAT gateway. You will need to have a Passion host server attached to one of the created public subnets. In each availability zone, a private subnet will be created. The first private subnet will have the primary SAP HANA database, and the other private subnet will host the secondary SAP HANA database. Then we will have the HANA system replication established between the primary HANA database and the secondary one. Going through the quick start components, we have validate param lambda function, which validate the parameters for the primary SAP HANA database. The lambda function will do the same for the secondary SAP HANA database. Now we have a new lambda function, pre-HA config, which is responsible for update the network config for the private subnet in the first availability zone. It will do the same in the second availability zone. Then it will create a full SAP HANA backup. Next lambda function is the HA config, which is responsible for set up AWS CLI, set up AWS tags, disable the source and destination for the cluster instances, enable the HANA system replication on the primary node, register the secondary SAP HANA node with the primary. Here is the SAP HANA system replication direction. The HA-config lambda function will set up the coroutine key on the first node and copy it to the second node. After copying the coroutine key to the second node, it creates the coroutine configuration file. Then it starts the pacemaker on both nodes. Then it creates the fencing agent and the floating IP resource agent. Then it creates the cloned resource agent, and finally it creates the SAP HANA resource agent. Here we have another diagram describing the SUSE HA cluster and how it manages the SAP HANA database system replication. Now we will talk about the SUSE cluster components. But first, let's have a quick note regarding routing from internal. The current overlay IP address agent allows application servers inside a virtual private computer VPC to access protected SAP HANA server in that VPC, but it doesn't provide access to on-premises applications. It requires applications like HANA Studio to be managed inside the VPC via RDP or Jumpstart server. The Route 53 agent works around these restrictions by using a name-based approach to allow on-premises users to connect to the VPC. The two agents operate in parallel. The overlay IP agent routes traffic from the overlay IP address to the active node. The Route 53 agent updates the name of the SAP HANA server with the current IP address. We use SUSE OCF resource agents. The resource agent's directory path is /usr lib ocf resource.d/SUSE, and the fencing agent directory path is /usr lib 64 stanith plugins external /ec2. So we start with the first resource agent, SAP HANA, which is the agent for the SAP HANA database in the scale-up scenario. It manages the takeover for an SAP HANA database with system replication in an OCF master-slave configurations. The resource agent controls the start and the stop operations, and it checks the synchronization status of the two SAP HANA databases. The next resource agent is SAP HANA Topology. It helps to manage the two SAP HANA databases with system replication. And the next is AWS VPC Move IP, which is used for the application server to database traffic. And finally, the EC2 fencing agent, which is the fencing agent used in AWS infrastructure. Before we finish this section, I would like to add a note regarding the /etc/hosts file, which describes a number of hostname to IP addresses mapping for the TCP IP subsystem. It's the recommended name resolution method for the cluster. The next section in this presentation will be dedicated for the resource agents and constraints. We have four resource types: the primitive resource, the group resource, the clone resource, and the multi-state resource. The AWS VPC Move IP resource agent is a primitive resource without special conditions, and it runs on one node. The SAP HANA Topology resource agent is a clone resource, and it runs on both nodes. The SAP HANA resource agent is a multi-state resource. It runs as an active or master resource agent, and it runs also as a passive or slave resource agent. The constraints are used to influence resource agent behavior. We have two constraints used in this quick start deployment. The first constraint type is collocation, and second constraint type is order. The call IP primary collocation constraint, set the floating IP resource agent to run on the same node runs the master or the primary SAP HANA database. And the ORD SAP HANA order constraint ensures that the SAP HANA topology resource agent works before starting the SAP HANA master slave resource agent. Now we will look at the HA commands which will be executed during the lab time. The first command is crm_mon, which provides a summary for the cluster current status. We can use some options like -r, -f, and -n. The output of the crm_mon command will show the cluster node state and the configured resource agent and the nodes that run them. The CRM shell is a command line based cluster configuration and management tool. CRM command works both as a command line tool to be called directly from the system shell and as an interactive shell with extensive tab completion and help. The SAP HANA System Replication Show attribute shows Linux cluster attributes for the SAP HANA System Replication. The overall system replication state is shown as well as the HANA state on each node. There are two user accounts, HTTP admin and HA cluster, which are created during the HA and HANA setup. The passwords are set using the SAP HANA Quick Start field shown in this slide. The HA cluster user is the Linux user that is created during the SUSE HA configuration. The HTTP admin user is the SAP HANA SID admin user. We have the HTTP nsutil command, which is SAP command line tool that can set up or manage SAP HANA system replication. And finally, we have HTTP settings Python script that prints a human readable table of the system replication channel and their status. In this section, we will look at the first testing case you will work on during the lab time. Let's assume that the current primary database is pre-HANA. Then we will simulate a database crash on the primary HANA node. What is the expected outcome? Well, first the cluster detects the crashed primary HANA database on pre-HANA and marks the resource field. Then the cluster promotes the secondary HANA database on SAP HANA to take over as a primary. The cluster migrates the IP address to the new primary on SAP HANA. Then the cluster starts the database on pre-HANA and joins as the secondary, and finally it runs resource cleanup. So let's see the expected outcome in details. The primary HANA database is crashed on the primary HANA database node. The cluster detects the crashed primary HANA database on pre-HANA and marks the resource field. The HANA takeover will be executed. The cluster promotes the secondary HANA database on SAP HANA to take over as a primary. The cluster migrates the IP address to the new primary on SAP HANA. The routing table will be updated to route the traffic to the new primary database. The cluster starts the database on pre-HANA and joins as the secondary. In this section, I will discuss some quick tips and tricks regarding cluster management. If you need to change the primary cluster node, you need first to identify the SAP HANA Master Slave Resource Agent name. Then you need to create a move away from the primary node rule by using the force option. What is the expected outcome? Because of the move away force rule, the cluster will stop the current primary site pre-HANA. After that, the cluster will promote the slave resource agent on the secondary site SAP HANA to be the new master if the system replication was in sync before. Sometimes things change. So, software version control is essential. All cluster nodes should run the same software versions. We have more than one way to access the SUSE official software repositories. First, the on-demand EC2 instances have access to the public cloud update infrastructure. You can use your SUSE Manager server to patch your cluster nodes. You can also use the SMT or RMT dedicated servers for the cluster nodes. Here, a quick brief about the commonly used zipper commands to patch the cluster nodes, like zipper install, zipper update, zipper patch, zipper list updates, zipper list patches, and here more zipper commands like zipper list repositories, zipper search package, and zipper info. And finally, before patching or upgrading your cluster nodes, always backup your application software, test if the backup can be restored, and always run the procedures in a testing environment first. Thank you for your time. Please submit your questions online. Hello and welcome to the SUSECON Digital. This is Abdurrahman Mohammed, an Alliance Solution Architect at SUSE. I will demonstrate some related actions to an SAP HANA HA cluster operating on AWS. The labs that are listed in this recording will cover the following. First, a failover test case from the primary SAP HANA node to the secondary SAP HANA node. Second, migrating a primary SAP HANA rule using the cluster migration commands. Before we start, let's first start by a note regarding the connectivity to the created SAP HANA HA nodes. The SAP HANA HA cluster primary and secondary nodes are deployed in private subnets. The SAP HANA instances cannot be reached directly over the internet unless there is virtual private network VPN or direct connect established between the client network where you are accessing the server from and where the servers are running. Use the Passion host server deployed in the public subnet, already deployed or set up using the Quick Start template, or AWS Systems Manager to access the SAP HANA servers. During this lab, I will divide my screen into two terminals. The upper one here will be dedicated for the first node in my SAP HANA HA cluster, which name is node 01 and its SAP HANA site is HAB. HAB stands for HA primary. And the lower terminal here will be dedicated for the second node in my SAP HANA HA cluster, which names is node 02 and its SAP HANA site is HAS. HAS stands for HA secondary. In my case, I have configured my SSH configuration file to include my Passion host server related information. These configurations basically contain the Passion host server IP address, the Passion host server hostname, and the Passion host server SSH key. If you don't have such configuration, then you may use this command. You should replace the SSH key by the SSH key you injected in the Passion host server during the installation time, and replace the Passion host server IP address by the Passion host public IP. As I explained, I have configured my SSH configuration file to include all of this information, so I will simply SSH to the patient host server using the SSH command in my two-terminal window. Here, I will not execute that command. I will SSH to my patient host server, and I will do the same in the other window. Now I have logged in to the patient host server. Again, I will use the same SSH approach to access my SAP HANA HA cluster nodes. So from my first terminal here, I will SSH to the first SAP HANA node, node 01. And I will do the same here, but this time node 02. And finally, on both nodes, I will execute hostname command in order to verify the host names. Here, it's node 01, and here, it's node 02. The first thing to do after using the quick start template to deploy the SAP HANA HA cluster is to validate some basic functions like the cluster status and the SAP HANA system replication status. So let's check the cluster status by executing the crmmon command. I need first to switch to user root. So from node 01, copy node 02. I will switch to user root, and then I will be executing crmmon command. As you can see, node 01 and node 02 are up and running. The primary SAP HANA node is working on node 01, and the secondary SAP HANA node is working on node 02. The floating IP resource agent is working on node 01. The next step is to validate the SAP HANA system replication state using the command SAP HANA show attribute. Actually, SAP HANA system replication show attribute. So I will be executing it from any node. Here I will be executing it from node 01. As you can see, the operating mode is log reply, the system replication mode is sync, and sync state is suck for node 02. So the system replication from node 01 to node 02 is fine. Next, I will validate the SAP HANA system replication state using the command https util. First, I need to switch to the SAP SID admin user, which is HTTP admin in this lab. So from node 01, I will be switching to that user, and then I will be executing https util command. I need to enlarge this terminal. Here you can see all the information about system replication status, and it's reported from the primary SAP HANA node. I will repeat the same steps from node 02 to show the system replication status from the secondary SAP HANA node. I will switch to the SID admin user, and then I will be using the same command, same https util command. And here all the required information about the system replication status from the secondary SAP HANA node. Finally, I will validate the SAP HANA system replication state using the Python script system replication status. From node 01, I'm still logged in as HTTP add, so I will be using the script here. You can see all of the information that you need about system replication. The most important one here is the overall system replication status, which is active. Now it's the time for the first testing case in our lab. We will test a failover scenario observing how the SUSE HA cluster behaves when the primary HANA database crashes. Before going through the test case, I would like to mention two important SAP HANA Resource Agent settings. Those settings govern the cluster behavior. So first, the preferred site takeover, which defines if SAP HANA Resource Agent prefers to switch over to the slave instance instead of restarting the master locally. And second one is automated register, which defines whether a former primary should be automatically registered to be secondary to the new primary. With this parameter, you can adapt the level of system replication automation. So in order to see the current values, we need to check the cluster status first by executing the command crmmon. So here, and then I will be checking the needed parameters values. As you can see, the preferred site takeover SAP HANA Resource Agent parameter values is true, and the automated register SAP HANA Resource Agent parameter value is also true. So the question is, what is the expected outcome after the database will be crashed on node 01? Well, the cluster identifies that the node 01 went down, then it promotes node 02 as a primary database. So from the secondary node on node 02, I will run crmmon command to see the current cluster status during the failover scenario. So here, and then from the primary node on node 01, I will run the command SAP HANA System Replication Show Attribute in order to ensure that this synchronization state is SUC. So from here, well, it's okay. Node 02 is syncing fine from node 01, which is the primary node. So from the primary node on node 01, I will switch to the SID admin, which is user HTTP admin in this lab. Then I will crash the SAP HANA database. So first switch to the HTTP admin user. And then I will crash the database. Before executing that command, I need to keep an eye on the running cluster monitoring window on node 02 here. So hit enter. Now the pacemaker will identify that the cluster node 01 here now the cluster will detect the stopped primary HANA database on node 01 and marks the resource field, as we can see. And the cluster is going to promote the secondary HANA database on node 02 to take over as a primary, which we can see here. Also, we noted that the floating resource or the floating IP resource agent has moved from the node 01 to node 02, the new primary. Because automated register value is set to true, the cluster registers the filled HANA database against the new primary. Let's wait first until we see it's a master here. Okay, the HANA database or the master HANA database should be working now on node 02. From node 1, I will be executing SAP HANA System Replication Show Attribute here. So I can see that node 01 is not syncing from node 02 now. So we need to wait some time. Still not working. Now, node 01 is syncing fine from node 02, which is the new primary node. The last thing that I need to do here is to clear the failed actions messages here. So I need to execute this command to refresh the current status. And now everything is okay. If I execute the SAP HANA System Replication Show Attribute again, everything is okay. It's syncing fine. The letters of node 02 is the primary here and secondary for node 01, and numbers are 4, which is fine. So that's it. As a result of crashing the primary HANA database in the previous lab, the current primary HANA database is working on node 02, as we can see here. And the current secondary HANA database is working on node 01, as we can see here. On any node, ensure that node 01 sync state value is stuck. So I will be using the command SAP HANA System Replication Show Attribute here. Okay, node 01 is syncing fine from node 02, which is the current primary. I need to identify the SAP HANA Master Slave Resource Agent name by executing the command CRM resource status here. As you can see, the SAP HANA Master Slave Resource Agent name is MSL underscore SAP HANA underscore HTTP underscore HTTP00. On node 01, I will monitor the cluster status during this activity by executing CRM1 command. And let's close this. On node 02, I will create a move away from this node rule by using the force option. Before I execute this command, I need to give a brief about the expected outcome. Because of the move away force rule, the cluster will stop the current primary site, node 02. After that, the cluster will promote the slave resource agent on the secondary site, node 01, to be the new master if the system replication was in sync before, which we have already checked. So let's hit enter and keep an eye on the running cluster monitoring window on node 01 to see the expected outcome. Hit enter here. Well, the SAP HANA database is stopped now on node 02. It's being stopped on node 02. So now it's stopped. the SAP HANA database on node 01 is being promoted to be the new primary node here. Notice the floating IP resource agent move from node 02 to node 01. Let's wait until the promotion for the resource agent on node 01 done. The new primary SAP HANA database is working now on node 01, as we can see. I need to confirm that the secondary node has completely taken over to the new primary rule by executing the command SAP HANA show attribute, system application show attribute here. As you can see, node 01 is the new primary node, and here also the primary node and number here is 4. Node 02 is not syncing. The system replication is failed now because node 02, the database on node 02 is being stopped or has been stopped already. So we need to clear the SAP HANA master slave resource agent location constraint ban to allow the cluster to start the new secondary. So I will be executing this command. Now database is being started on node 02 and it will be registered to the database on node 01, which is the primary node. We will wait until the cluster registers node 02 as the secondary HANA database. Now the HANA database is working on node 02 as the new secondary node. If I execute SAP HANA system application show attribute again, saying that still is failed. So we need to wait for some time until the system application done successfully. Wait for some time. Now execute the command again. Okay, so now node 02 is syncing from node 01, which is the primary node. Thank you for listening.